Hello guys, Winston here. A couple months before I stopped making videos, I cleaned out my local Home Depot of these Dewalt Deep Pro organizer bins at what was effectively 50% off MSRP. The price was just too good to pass up for an above average quality organizer with removable bins and a sturdy, crystal clear lid. Certainly a step above the Stanley Sortmaster containers that I already liked, and way better than those run-of-the-mill Harbor Freight organizers. My initial goal was to migrate some of my HDX organizers to these to give my fastener collection room to grow. But one thing I wasn't thrilled with was that each of these bins inside the organizer was quite large, and there were only 10 bins per case. To make the Dewalt system work, I would need to subdivide the bins to make them more versatile and efficient for the varied quantities of smaller items I'd be putting inside each case. That's where these 3D printed inserts come in. I wanted to initially subdivide each bin into 2 to 4 smaller bins that could be removed individually, but if you want the bins to not rattle around, they would ideally need to be a pretty tight fit. And each standalone sub-container would need to be pretty tall as well to reach the bottom, which isn't so great for stability once you remove them from the Dewalt bin. At some point in my ideation process, it did cross my mind to check if someone had already designed inserts for Dewalt storage systems, and it turns out that some people had, except these were mostly for the T-Stack system, which differs from the Deep Pro system in one key way. T-Stack doesn't use triangular notches in the lid to help retain the position of individual bins, so any inserts for the T-Stack system would interfere with the Deep Pro system's lid unless I did some STL modding. I did find one seller who had designed their own inserts for the Deep Pro system, but the price per bin was just a little too high for how many I needed, so I decided to just make my own. These Dewalt bins, like most injection molded parts, have a draft angle, which means if I wanted my inserts to sit securely in the original bins and still provide the maximum amount of usable internal volume, they too would need to be designed like an injection molded part with a draft angle. Now, I know of 3 main ways to design this kind of feature in Fusion 360. One is to use the draft angle tool. This tool lets you pick a reference plane and faces to angle in or out relative to that reference plane. If you have existing geometry and you need to make modifications to it, especially for step files that you can't edit parametrically, the draft angle tool is great. But if I'm starting from scratch, I don't actually like using this tool because it can lead to errors or weird dimensions that start compounding over time. For example, if you take a box that has straight perpendicular walls and then apply draft angles inside and out, you'll end up changing the wall thickness. This is bad not only because weird dimensions bother the heck out of me, but this would actually be undesirable if you were designing a real part for injection molding. A consistent wall thickness is super important because plastic shrinks as it cools. A part with varying structural wall thicknesses can warp coming out of the mold. Option 2 for creating a tapered feature is to loft between sketched profiles. This method kinda sucks, and I'll explain that in greater detail later. What I like to do is use the extrude tool with taper angles, and I'll run you through how I use that here. Before I can start modeling my nested bins though, I need to figure out 2 key values, the wall thickness of my part and the draft angle. I think anywhere from 1.5 to 2 mm is a fine shell thickness for most designs that will be printed solid. Draft angle though is a little less arbitrary. I need to match the exact angle on the Dewalt bin so that they fit snugly. This is something you can measure directly with a digital angle finder, and those are pretty cheap nowadays. But if you want to be even more frugal, you can do this with your smartphone and the compass function that most of them have built in. If the original designer of the part you're trying to reverse engineer wasn't a monster and stuck to using a draft angle of single or half-degree increments, you should be able to figure out the correct draft angle with a high degree of certainty. I recommend doing this a couple times with the part pointing in different directions to eliminate the possibility of any magnetic bias from your environment. With these 2 critical parameters defined, as well as a few others for housekeeping, I could start drawing out the profile of my organizer insert. I'm starting from the top since that's the only place on the Dewalt bins I can measure directly. I figured out the internal dimensions of the bin as well as the positioning of the little locating groove in the corners. Do I need that little rib there? No. Do I find it satisfying to have in there? Yes. I extruded out my design a millimeter thick just to print and verify. You don't need to model the whole bin to confirm just a few critical dimensions. By the 3rd iteration, I had everything to my liking. Once I had a profile I could trust, I then extruded that profile downward with a taper angle. This section needs to go down just far enough to sit on the intermediate ledge in the Dewalt bins. That took an extra try to get right as my first prototype sat a little lower in the bin than I wanted it to. Before I got too far along, I also wanted to do a little bit of cleanup and optimization for 3D printing purposes. In particular, that little rib on the corner of my bin would need support if I left it like this. To avoid that, I lopped off the corner of all my ribs with a chamfer to eliminate a harsh 90-degree overhang. Then, to model the bottom half of the bin, I created a sketch that was inset from the profile of my extruded face by 2mm, and then continued extruding downward with the same taper angle. If I had wanted to create this bin by lofting between sketched profiles, I would have needed to know the dimensions of the cross-sections at the top, middle, and bottom, and pulling internal and external measurements off thin, floppy, inexact plastic parts would have been an absolute nightmare. It's much easier to start with one master set of dimensions as your ground truth, and then just let the final shape of the box flow out through the process of extruding with a taper. Everything stays relative to your original dimensions, and any necessary changes and corrections are much easier to track and propagate through the design. Once you have your external bounding volume set, you can hollow out the design with the shell tool, leaving you with a part that's exactly the same thickness everywhere. At this point, it's basically just a matter of configuring the interior volume however you'd like and optimizing the part for 3D printing. Here, I'm liberally and questionably applying chamfers to eliminate horizontal overhangs. I'm also lopping off the corners to account for these somewhat awkward triangular locating features in the lid of the Dewalt organizers. I'm adding in dividers in this bin as I see fit, and also tossing in some radii to make it easier to pull small fasteners out of the corners of this bin. The larger size bins got the option of 2 to 4 compartments, and the smaller bins only got 2. Now, this is not how you should do it if you are actually injection molding these inserts, since that radius in the bottom of the compartment messes up the shell thickness in that section. You would get visible sink marks in the face of the plastic if you did it like this. Instead, you would want to radius the outside corner before shelling the whole thing, but since I'm not actually injection molding these bins, I would rather have a big flat surface on the bottom of my bins to maximize bed adhesion. I exported my 3 variants out to STL files and ran them through Cura's default settings for my Ender 5 Pro. Every now and then people will ask me how I like this printer, and I have to admit I am constantly impressed by how well it runs. It's not the fastest printer, and there are some minor stringing issues with the nozzle and cooling system. I guess it could partly be my filament, but reliability-wise I've been blown away. It's not difficult to level the bed, and once you get it set to your liking you kinda just forget about it. It'll run without any drama for months or years, and the flexible magnetic bed that comes stock is actually awesome with PLA. This isn't sponsored, by the way, and I know there are other really good printers you can purchase if you do your research, but for a basic printer I think this is a pretty good value. The print time for 1 large bin and 2 smaller bins was about 11 hours plus or minus 1. So on the weekends I could start a print in the morning and then start one in the evening before bed. On weekdays I would just run one overnight. Over the course of a couple weeks, I slowly amassed a collection of printed containers until I had enough to begin migrating my larger fasteners over to the Dewalt system. The resulting setup ticks all the boxes I'm looking for and is super satisfying in how tightly it seats in the original Dewalt bins, yet falls away by gravity. I probably wouldn't use these for screws smaller than M4 just because the lid doesn't seal super tightly against the top edges of my subdivided bins, but if I used plastic bags or an intermediate container, these are actually perfect. And since I didn't make these inserts full depth, I do have some room under the bins for oversize or overflow hardware. I still need to make an Adam Savage style rack for these Dewalt organizers, but I think at this point I'm pretty content with the end result. If you have Dewalt organizers and a 3D printer, I'll be making the Fusion and STL files of these inserts available on my website for a couple dollars. The Fusion files are kinda just for reference, by the way, they aren't perfect. There are a couple little things that'll break if you mess too much with the parameters, and I don't really like the order in which I slathered on chamfers and other optimizations for 3D printing, but at the very least you can figure out my design intent and hopefully learn from them, and of course the STL files are there if you just want to print these and have working bins. Folks on Patreon already have access to these files, and I thank you for your continued support. I know I haven't been uploading a ton of stuff lately as life has gotten rather busy, but hopefully I'll be starting to work through my video backlog effective immediately. I want to thank you all very much for watching. I know there was no subtractive manufacturing in this video, but hopefully you got something out of seeing my design and iteration process. I'll see you all soon with more CNC content and DIY nonsense.